Hi everyone, welcome to AEON Laser Crafts. In the last video you might have seen the unboxing and assembly of Ortur Master Laser 2. In this video I will focus on setting up the laser and doing some tests. Since the last video I installed Lightburn software and seems that it's much more user-friendly versus the freeware Laser Gerbil. For now I will use that one as the main software to prepare my projects. As promised last time, in this video I will show you the first run and some tests with the new Ortur Master Laser 2. I wanted to start with something simple, so I did some shapes of rectangles and circles, starting from 1 mm radius, going up, just to check how tiny elements the laser can cut. I focused the laser and hit the button. Here you see there's a lot of fumes, a lot of residual. If you look closely, the laser is actually burning the wood, not cutting it. So the second pass, the second attempt, I decided to do with air support that I've already upgraded the laser with. Well, here you actually see a small fire, which shows that you should always supervise the laser's work. In the second run, I've turned on the airflow, which gives you some idea what benefit it does. It removes the fumes and the residual from the cutting. It makes the cuts much cleaner and prevents the wood from burning. It appeared the elements were too small, so I've increased the scale a bit in the Lightburn. Now it's going much easier. In the top of the screen you might notice I'm showing you the pictures of how I connected the air compressor. It really does the work in supporting the cutting process. However, I think the air pressure that I've set was too small to remove all the fumes and residuals, so I need to experiment with that. With the first test the laser was not cutting through the material, so I've increased the amount of passes up to 3 and also enlarged the shapes. It appears fine-tuning the laser for cutting small elements is not that simple. Here I increased the airflow, so you see there are no more burn marks around the cutting edges. The attempts 1 to 3 were a complete failure. But the last one, after increasing the airflow, I would say it gave pretty decent results with no burn marks, and the cutting edge were quite clean. However, despite the cutting, the plywood was not entirely cut through. As you see, you couldn't take the shapes out. The issue is that the 3 mm plywood is not the easiest material to cut with a diode laser. One important remark is that the cutting point is not a circle, so it's actually a bar shape, which means that it cuts better in one direction than the other. Such circle is actually a perfect example because half of it is cut through and the other half is not. So it shows you different amount of power focused on the material, depending on the direction the laser is traveling. Then I tried 1.5 mm plywood cutting with just one pass. It was much easier. Here I put a lot of airflow just to ensure all fumes and residuals are removed. Important thing to remember is that the airflow might cause your things to fly around, so here I used some masking tape just to put the object in place. The cutting took some time because the speed was just 1.6 mm per second and 100% power. The small parts that actually were cut out did fly around, but fortunately they didn't interfere with the laser and the other cutting points. This design I made to cut is based on the Fibonacci sequence. It's called also the golden ratio spiral. Here I was pretty surprised that the laser did a really good job cutting the small materials. The cutting edges were pretty decent. There were not much of the dirt on the front nor the back side of the cutting material. Here are some close-up shots with macro lens to show the final effect. The worst part was the hanging hole of the pendant, and here in the next bit you can see actually why. The issue is that if you look closely, those circles are more like elliptic shapes because of the focal point, which is actually a rectangle. It delivers more power to where it has a longer sight. Then I've decided to test the engraving capabilities of the laser. I've started with AEON Laser Crafts logo engraved on plywood. In addition to that, I tried engraving also the barcodes to easily access the links to the social media platforms. However, plywood is not the easiest material to engrave on, and the barcode scanner couldn't really read that. Anyway, I used too much power, so the engraving was too deep. Second try was with a bigger size of the bar and lower power of the laser. However, still no luck. I think it was because I tried to engrave it on plywood, which is not the easiest material to engrave on, and a wood grain makes it difficult for a scanner to read the code. Definitely, I need to experiment further to use different settings of the laser and try to optimize the focal point. Next engraving, I tried with balsa wood, which comparing to plywood, I needed to decrease the power of the laser quite much because it was burning the material. Cutting was extremely easy. That is just 1 mm thick balsa wood, which makes it pretty transparent. With using flashlight, one can see a nice wood structure. Next test is engraving Mandelbrot set on plywood. I was able to find some high quality graphics on the internet, and here I've decided to turn it into a vector graphic. The Lightburn software is very good at showing how the laser will travel and how much time it should take. Normally when you engrave, the laser covers the whole outline of the object with traversal moves. There is an interesting feature called flat fill, which allows the laser to travel just to the areas that are supposed to be engraved. This particular example gives you the best comparison between these two methods. So here in the inside of the Mandelbrot set you have blank area where the laser will not be doing any work. With the traversal moves it would take 1 hour and 28 minutes to engrave that shape. If you turn on the flat fill, it will decrease to just 45 minutes. Eventually I engraved it on 20 by 30 centimeters plywood. I was positively surprised of the level of details that laser delivered. If I engraved on a crater format, the final result would be even better. Next try was engraving on oak veneer. I found some graphics of one of my favorite artists, a trio from Berlin, Moderat, the first album. The black and white album cover was very easy to turn into vectorized graphic in Lightburn. Playing with the cutoff and threshold can give very interesting outcome. Again, I've used the flat fill option as the completion time was much shorter than the original method. Here I've used similar setting as for engraving plywood, but it turned out that oak veneer absorbs power much more than the plywood. As a result, the engraving was very deep. In some areas it even got burnt through. Well, I didn't see that coming. Another thing to remember is that materials that like to bend needs to be kept in place to stay at the same height or the same focal length. If the distance of the material is different, then some areas will get more or less power depending on the focal range. The overall result was not bad, but if you look closely to the bottom of the cover, you will see that it was quite heavily burnt. Here I did some close-ups with macro lens, which shows that the engraving was definitely too deep. A lot of material was burnt and also shows how uneven the depth is. One mistake I made is I didn't use any air support. That is why the material was probably burning too much. Next test was engraving geometrical shapes onto a cardboard. That one was really satisfying to see, how the laser is engraving the hexagon spiraling in. Here probably I could still work on a focus to make the lines even thinner. One remark toward engraving cardboard is that slightest touch will spread the burn residual all over the engraving. In the future I definitely need to work on finding some solution like lacquer coating to prevent that from happening. I think the next test was the most interesting. I've decided to play a bit with illustrations from Harry Clarke, who was a famous book illustrator in the early 20th century. This particular illustration comes from the edition of Edgar Allan Poe's Tales of Mystery and Imagination, which was printed and published in 1923. I was able to find the graphic with quality good enough to vectorize it in Lightburn. For this test, I would say the level of details was acceptable. I decided to start with the plywood engraving, but the format I chose was definitely too small to really show at least some sensible part of the details in the picture. In order to show the illustration with all the details, I would really need a huge format to do so. Just out of curiosity, I decided to do a part of the graphic in a bigger scale, engraved on cardboard. Well, I have to say that was much more enjoyable. The structure of the cardboard is very even, which makes it a good material for engraving. If you liked the video, please hit like and subscribe. Feel free to add a comment. Anyway, thanks very much. I hope I'll see you soon. Bye.